Okay, so we're going to finish off our little discussion about for loops. I skipped all the examples last week, and I skipped all the exercises last week, so we're running out of time, and I really want to do them because they're the most informative thing. I also went to the ECHA for the first time, so I can tell you my ECHA story now, or I can tell you the ECHA story at the break. You want to save it, or you want to hear it now? Not all at the same time, everyone. I'll tell it to you at the break. I met a famous Australian icon at the ECHA within the first 4 minutes of being there. So you can stew and think about who the great Australian icon is, and then let me know what your guesses are. It's not a Kiwi, so it's Australian. Okay. So last week we introduced a new control structure called the for loop. And this was part of the repetition sort of phase of our developing tools for an imperative programming language. And what the for loop allowed us to do is that given any enumerable structure, okay, if you want to work and talk, leave. No more am I doing this. Attendance at lecture is optional. I'm really grumpy in the morning because I have a toddler that keeps me up all night and then gets up at 5 in the morning because he just loves life so much and doesn't want me to sleep. So my patience cup is much emptier than it normally is. And usually around the time assignments are due, people come to these lectures and treat me like a YouTube video. I'm going to get tilted. So please, if you want to talk through these lectures, go. You're not obligated to be here. There's various forms of getting these lectures asynchronously. Okay, so that being said, well, if you talk during this lecture, I'm going to personally shame you. That's going to be your punishment. I'll turn around my camera and point the YouTube at you. Okay, so we have this notion of having some type of data structure, and that data structure like somehow provides some type of order, right? We can walk through it. It's like a list. So last week we were dealing with strings. Strings are just sort of a sequence of characters. So we can use for loops to walk through them. So here is an exercise. Let's give it a go. Wish technology would work better for me, but whatever. Let's write a function called remove that I'm going to give a character, but really this is a string of length 1 because we don't have characters, and a string. And I want to return a string with all of the characters of C removed, right? So if I want to remove B from Bluey, you're going to be left with L-U-E-Y. If I want to remove small b from Bluey with a capital B, nothing gets removed. And what we're going to do today in the second part of this lecture is go through all of the string methods, right? So a lot of these are built in, but I want to like develop the tool first, right? So this also connects with a larger discussion I've been like on the ed stem. The tools that we've given you are more than sufficient to solve the assignments. At least we're approaching it. In fact, like remember, like if statements and loops are powerful enough to do anything with computers. Now, what I'm afraid is happening, and what happens every year, is that there's like a sub-collection of the student body who believes programming is about searching Google to figure out what command to call that like implements the thing that we've asked you to do. That's not how we program. You can't start Googling for answers until you know how to program, because you don't know enough about programming to reject stuff that's obviously wrong. Now, the same goes for ChatGPT, right? ChatGPT, you need to be good enough at programming to know when ChatGPT has catastrophically failed, which Stanford has just measured to be 50% of the time minimum. Okay? Third, these assessment pieces are practice for the exam. Practicing computer science is the only pathway to actually gaining competency in it. Okay? If you don't do these assessment pieces and struggle with them and do them by yourself, you're going to fail the exam. Every year we have people who get like perfect on all the assessment items and then do miserable on the exam. Okay, so you're not going to pass this course by maximizing your marks in the assessment items. That is the it's not, well, like I don't care ultimately, right? Because you'll fail the exam. Like that's where we're going to catch people who aren't actually engaging in the work. I will catch people for plagiarism because if I don't write people up for plagiarism, I get in trouble because of with a class of 1,000 students, if I don't catch anyone cheating, that means I'm not doing my job. So also make sure not to cheat. But I'm really trying to, like, I don't want repeats of this, of like, dozens of students emailing me saying, I did so well on my assignments, but then I got 0 on the exam. And it's like, wow. Like when you do worse than random guessing on the exam, like I can't give you a certification for being able to program. So like if you're the hardest part of this course for novice programmers is right now, right? Because you're starting from nothing, right? As we develop programming skills, like the assignments will get more difficult because they'll comprise more of like the course material, but you'll be better at programming, right? So for many of you, you just got to get over this hump. And to be confused is something you're going to have to become comfortable with, right? There's an adage that confusion is the sweat of learning, right? So you want to be sweating a lot, right? Because you're novices. And though we appreciate that it's difficult, this is why we've like provisioned so much help. Right? This is why there's a help center that's open 4 days a week, like 7 hours a day. This is why we have an EdSTEM where you can get an answer within 5 minutes. So please do engage in this and try not to Google answers to stuff. If you want to Google, like, how does a for loop work? That's okay. If you want to Google, how do I use a for loop in order to do the following assignment specification function? That's less okay, right? And certainly ChatGPT is not something you should be consider using. Okay, so let's write a function that removes a character from a string. So I'm just going to call it like this. Definition remove. This is a string. This is a string as well. And this is going to return a new string. And it's going to put a precondition here that the length of C is 1, right? So we're actually giving a character. Remember, if we are allowed to put in as many preconditions as we want, it's up to the user to read them and to invoke our function properly. And if they don't invoke it properly, our function is not guaranteed to work. Same is true for your assessment, right? When we say develop a function with the following input contract, you don't have to worry about what happens if a user passes the wrong stuff to your function. Your function's not supposed to work in that case, right? So write your assignment under the assumption that we're going to pass your functions the correct stuff, because they're not supposed to work if we're passing them incorrect stuff. Okay, so we had, what was our one example? Something like remove B from Bluey, right? To get Louis. So this just shouldn't be too bad. So what I want to do, so what I normally do is just program in pieces. Like you don't have to do this in order. So I'm going to do something like, okay, I need an answer. I'm going to have to accumulate on something and then I'm going to return it. What I mean by accumulate is I want to sort of walk through the string C's, right? So this is look at every character in C's, right? That's what the function is going to, that's what the for loop is going to allow us to do. Then I can say something like, okay, so if C is equal to X, what should I do? So I'm walking through the string C's. I'm looking at every single character in it. What am I supposed to be doing here, right? So first of all, if I'm going to accumulate, which is a word that we use when we have some type of variable and we keep adding to it. And so this seems like an appropriate place to accumulate something, but I'm not adding numbers here. If I was adding numbers together, I could start the accumulator at 0. I'm building a string. So what's the equivalent 0 for like the string type? Yeah, the empty, not the space, the empty string, right? This is basically nothing, right? So here, if C is equal to X, then I well, I don't want to do anything, so I'll just write pass maybe. Else, I want to actually accumulate, so I'm going to add X to the end of my answer. So this is going to work. Let's check. My hands are so cold. Remove B from Bluey. Louis, okay? How can I simplify my code? What have I done that's like not right? Even though my code's working, the code is longer than it needs to be. Why? And how can I fix it? Yeah, like what's the point of having an if pass branch? So I see this a lot as well on the homework that students forget that you don't like there's a proportion of students who believe that only if else exists and nothing else. So if you ever see something like this, the condition is actually checking if c is not equal to x and something like that. So step one is to get your function to work. Step two is to sort of look at it and ask, did I have anything in here that's like technically a little bit suboptimal? Okay, so let's go out, check this, see if this is working. Perfect. Let's see if I remove this from this. Okay, we're good. Let's do another one. Let's capitalize every alphabet letter of a string. Right, so if you have the expression boom goes the dynamite, it would change all of those alpha characters to the capital version, but it would leave the exclamation mark the same, right? Because that's not an alphabet character. I think maybe you'll remember this meme, the boom goes the dynamite meme. And you guys can search it. These are old memes. How can we do this, right? So, and this may, if I were to deploy this in the class, I'd feel that a lot of people would start searching Google for like, how do I capitalize stuff? And I'm saying, we have for loops. I told you how to compare strings, and we have variables. We have those three tools. How can I use those three tools to do this problem? We don't have to go look up some library command to do this, because for one, ultimately the library command is written in Python. So we should be able to duplicate that library command. So let's just think about this. Like, what are we going to have to be able to do in here in order to accomplish this function? You're already talking about how do we do it. I'm asking like, what are the things that like have to be done? So for example, I'm going to have to detect if a character is a character and not a symbol or a number. I'm also going to have to detect if that character is a lowercase character or an uppercase character. And I'm also going to have to be able to convert lowercase characters to uppercase characters. So let's work on all of those things like individually. But before I even started programming, I'm like, oh, okay, if I'm able to identify characters as being lowercase and uppercase, and able to identify characters as either being characters or non-characters, and convert lowercase characters to uppercase characters, then I'm done. Then I can do this, right? So it's just incumbent on us now to actually design those things. So what did I? Okay, so this is going to be capitalized. I'll just call it cap because my hands are freezing, and I want to do something like capitalize AAA, something like ABC, ABC, 1, 2, 3. This, right? That should end up being ABC, ABC, 1, 2, 3, that. Okay, so I'm going to do the same thing. I'm going to say, I have an answer. The answer is going to be a string. So I'm going to start accumulating. Let's start accumulating from the empty string. And I'm going to return that eventually. I basically do this every time I like program a simple function. Okay, next, what do I have to do? I need to look at every, should be easy. So for a character in the string, what do I need to do? Well, if C is a lowercase character, then accumulate its capital version. Okay, else, if C is a lowercase character, then accumulate its capital version. Else, accumulate it, whatever it is. Okay, so I'm just thinking very high level. I'm not even like putting Python in yet, but it's like almost Python. So how can I accumulate it? Well, that's easy. That's just answer. So this can actually be an else statement. This is actually an if statement. There's no such thing as then. We have something like this. So I'm going to accumulate C because it's fine. How could I test if C is a lowercase letter? You have enough tools to do this. Yeah. Oh, okay. Lots of hands. Yes, you in the baseball cap. We could, but can't we just compare strings directly? So why convert them to numbers to compare the numbers? So, okay. So what about you, sir? That's not a bad idea. So here's one way of doing it. Lower alphas. Okay. Okay, they're all in there. God damn, my hands are cold. Okay, but so you could do something like if C is in the lower alphas, then it's that. That's not a bad not a bad idea. Any other ideas? Yeah. Let's not use methods because then I would ask, well, how is that method implemented? Right. But that would be the correct answer for the third part of this lecture when I introduce string method. Yeah. Yes. Don't forget we have string comparisons. If C is greater than or equal to A and less than or equal to Z, then it's a lowercase letter. Now, how could you use this to determine if the string is a digit, which is part of your assessment? Yeah. Those are the only digits, right? So if you pull something out of a string and ask if it's bigger than or equal to 0 or less than or equal to 9, it has to be a digit. Anything else is not a digit. Okay, so that could be helpful for your homework. But in any case, if it falls within this range, then it's a lowercase letter. Okay. So I have to do something like answer plus equal, capitalize C. How do I capitalize C? What did we learn about strings last week? That all the characters are in a table, right? So if we know where all of the capital letters are and we know where all the lowercase letters are, we certainly know how much they're spaced by. So what do I need to add to a lowercase letter? Remember, the lowercase letters are sorted after the uppercase letters. So the question is, how much do I have to remove from a lowercase letter to make it an uppercase letter? Don't give me a number, give me a calculation. The difference between the capital A and the lowercase a, or capital Z, lowercase z. Okay, so how do I capitalize C? Okay, so we have C. That's we know for sure that's a lowercase letter. I look at its ordinal, right? That is a number. I'm going to remove from this number the difference between the ordinal of lowercase a and uppercase a. Okay. This is how much the lower and uppercase letters are separated by in whatever table that they're in. And then I just have to convert back to a character. So let's see how that works. If it works. Capitalize. Let's see. Let's take this. There you go. Okay. So you don't need, we didn't have to go look up on Google, how do we convert a lowercase letter to an uppercase letter? We had the tools for that already, right? So please do and try to use the tools that we've given you. That's the fun part of this, right? Using a limited number of tools to do something really complicated and incredible. Okay, so there's an answer to there. So in summary, for loops enable us to iterate through anything iterable, right? Things like strings, things like lists and dictionaries. Strictly speaking, they're not necessary. Strictly speaking, they are not necessary. Oh, we don't need for loops. While loops would have been sufficient, right? Because a while loop can repeat something an infinite number of times. For loop can repeat something a finite many times. but we use them so often that it merits their introduction. And you use for loops. For loops are one of the nicest high-level language features that Python provides. Okay, let's move on. List and tuples. Tuples. Okay, so strings, we learned that we weren't able to change them, right? Because they were designated as an immutable data type. Tuples are a larger category of types in Python, or data, that is also immutable. And this is going to be important for dictionaries. So a tuple is an immutable ordered collection of elements. These elements are not necessarily the same type and are not necessarily distinct. All right. So we use round brackets to designate tuples. That should be tuples, not list. I'll correct that. Okay, so here's how you create a tuple. Here's a sextuple, I suppose. Its first position is 0, second position is 1, 2, 3, 4, and 5. Its type is a tuple. It has indexing, right? So it's minus one element is 5. It has slicing. So how many numbers is it going to grab out of this tuple if I slice from 0 to 4? Who remembers the rule from last week? 3. You say 4? Remember, it's left inclusive, right exclusive. So it should 0, 1, and 2. Yeah. Oh, so 3. So you're right. 4. Yeah. But it's immutable. That means we're not allowed to change anything about the tuple. So if I try to change something about the tuple, what do we expect this to do? Yeah. Tuple does not support item assignment, or generally speaking, tuples are not mutable. Okay. So once you have a tuple, it's static. You can't change it. You can have mixed types inside of a tuple, right? This is different than a string, which was like a tuple of characters. So it doesn't really matter. So this is a tuple whose like odd positions are digits and whose even positions are characters. That's totally fine with us. Like suppose I give you another tuple y's with those values inside, right? 3C, 4D. Do you think I should be able to add these together? 1 and 3 make 4. A and C make AC. 2 and 4 make 6. Yeah. Yeah, I can't point-wise add these. Like I'm trying, the fact that like all of these values actually do individually support an addition operation in between them is like totally accidental. It wouldn't make sense for us to add arbitrary tuples to other arbitrary tuples point-wise. So we're going to do what my colleague there says and says, yeah, this is concatenation, that the same way we'd have a list. Do you think we can scalar multiply these tuples? Well, if we can add them, what does scalar multiplication mean? Repeated adding, right? So 2 times x's can be interpreted as x's plus x's. Well, it's returning a new tuple. Remember, when we use multiplication, this is a function invocation. So this is saying, I'm a multiplication function that has taken 2 and have taken a tuple, and I'm going to give you back a new tuple. The original tuple hasn't actually been modified. It was just input to a different function that created a new tuple and handed that back to you. So that was a good question. So we're going to get this, right? Basically what x is plus x is. Nomenclature. This is called a couple. This is a triple, quadruple, quintuple, sextuple, septuple, octuple, and so on. Right? In general, this is called an n-tuple. So you may hear me say the word n-tuple or tuple, and that's what I mean. Okay, so I said round braces designate tuples, but round braces also designated expression evaluation. So what should this be? Remember, ambiguity in the Python system is not allowed. Yes, sir. 3. But wait, didn't I say that brackets are used to build tuples? How can we rectify this? Pardon me? Huh? Yeah, so what we do in we'll get to there. So just using a single bracket is defaults to function expression evaluation. What's this going to equal? It's the worst sound in the world. Is that me? Yeah, type mismatch, right? Because the first one is the number 1, and the second thing is a tuple. What is the type of 1? It's an integer, right? Because this means evaluate 1. So 1 is 1, but 1 comma is a tuple, right? So that's how we delineate between like using brackets to like evaluate an expression and building a 1 tuple. Okay, so I can do something like 1 comma, a tuple with 1 thing in it, plus 2 comma, another tuple with 1 thing in it to get a tuple with 2 things in it. Okay, so it's just a little bit of a nuance. This appears on the exams maybe every other year. A tuple is an iterable object. So as soon as it's iterable, that means you can use a for loop to walk through it. So I can say something like for x in 0, 1, 2, 3, 4, print x. And it's just going to walk through that tuple and print 0, then print 1, then print 2, then print 3, then print 4. When I say print, what you should hear is, I don't know, do something with x. And I'm printing it to say, look, I have x and I'm holding its value. So at this point, you can intervene and use it to do a computation. Comparing tuples. So do you think this is sensible that the tuple 1, 2, 3 is equal to the tuple 1, 2, 3? If this isn't equal, what would equality be? Yeah. But is that what we want equality to mean? So my colleague there said, but maybe they're like at different memory locations. But like when we compare variables, is that what we're comparing? No, like we're comparing value. Yeah. Yeah, so I would say any sensible definition of equality on tuples would have to designate that this is being equal, because as you said, the first positions are equal, the second positions are equal, the third positions are equal, and they're equal length, right? So that seems like a very sensible definition of equality on tuples. What about this one? No, they're not equal. One has length 3, the other one has length 2, so not equal. Okay, what about this one? Is the tuple 1, is the triplet 1, 2, 3 less than the triplet 1, 2, 4? Well, as we said, we're doing this exactly the same way that we compared strings. Although I guess it's actually more accurate to say we're comparing strings as the tuple definition is defined. So is 1 less than 1? No, they're equal. Go on to the next value. Is 2 less than 2? No, they're equal. Go on to the next value. Is 3 less than 4? Yes. Okay. What about this one? Is 1, 2, 3 less than 1, 2? Well, is 1 less than 1? No, they're equal. Go on to the next one. Is 2 less than 2? No, they're equal. Go on to the next one. Is 3 less than nothing, right? Where nothing is always considered to be the bottom of the category. No, right? It's like doing a comparison against negative infinity. Is 1, 2 less than 1, 2, 3? Well, again, 1 and 2 are equal. So we move on to comparing nothing with 3. The nothing here is the bottom of the category. So is negative infinity less than 3? Yeah. Lists. Yeah. One, 1, 3. Yeah. One, 1, and 3. And you want me to compare it to 1, 2, and 1? Yeah, this should resolve in true, right? It stops at the second element and concludes. Yeah. Cool. Lists. Okay. So we so far have 2 data types which give us indexing, which are enumerable. That's the string, and those are tuples. They're both immutable. That means once we create them, we can't change them. We're now going to introduce lists, which have all of the same stuff that strings and tuples had, with the difference that lists are mutable, that we can change them. Now, because they're mutable, this actually creates a bunch of downstream problems that we're going to have to discuss. So let's do it. And then after this one, you get my Eka story. So a list is a mutable ordered collection of elements. These elements are not necessarily the same type and are not necessarily distinct, right? So you can really put whatever you want in lists, including other lists. Square brackets are used to create lists in Python. So here's a list. I'm going to put it into a variable called x's. whenever I have something that's enumerable, my habit when programming is to pluralize names when the name corresponds to something that has an index. So when I see X's, I'm like, oh, that's multiple X's. It's many X's. So I can have one student or I can have many students. And if I saw a variable for students, my presumption when I'm coding is that I can index this or iterate through it. Right. So I'm going to be holding on to this habit throughout the whole term. Right. So if you see an X, if you see me pluralize a variable, it's because I'm trying to indicate that it has index. Okay, so X is a list. Its first position is 1. Its second position, it's apple. The type of X's is a list. Remember, we're zero indexing in Python, so the 0th position is 1. And because this is now mutable, I'm now unable to do something like this. I can say the 0th position of X's is going to get the first position of X's times 2. So if I execute this command, what is going to be at X's at 0? Well, what's X's at 1? Apple. What's 2 times apple? Apple, apple. So what's going to be put in X's at 0? Well, apple, apple. Okay, so cool. Lists are mutable. Looping over lists, right? So here's just the list. And I'm just going to say for X in X's, isn't that a nice sort of syntax, right? For the singular X in the pluralized X's. Here you go. I've proven to you that I've set X to every value in that list. Okay. Comparison. Same game, right? Is 1, 2, 3 less than 4, 5, 6? Yes, right? Because 1 is less than 4. Is 7, 2, 3 less than 4, 5, 6? No, because 7 is not less than 4. Is the empty list less than 1? Well, I said you're comparing nothing with 1. And the nothing's always going to be the bottom of the category. So is negative infinity less than 1? Sure is. These comparisons aren't overly necessary. I don't think we use them very often. I just wanted to show you them for completion. Membership. So this is useful. We can say, is the number 1 in the list 1, 2, 3? Sure is. Is 0 in 1, 2, 3? No. How about is 1, 2, 3 in 1, 2, 3? No, because that's the number 123. Yeah. Is the list 1 in 1, 2, 3? Yes or no? Yay or nay? Okay, so I hear some confusion. Let's look at this here. So is 1 in 1, 2, 3? Whoops. 1 in 1, 2, 3? No. Okay, but is 1 in 1, 2, 3? Yes. Because this I'm asking, is there a list of length 1 containing 1 in the list? Because I said list can contain anything, right? So list can contain lists, right? So the first this is saying is this list in your list of lists, right? So it's a little bit nuanced in that way. So that is false. Here's some useful methods that we're going to use when working with lists. The first one is append. You're going to use this a lot. If I give you a list, I can say add 3 to the end of it. So remember, we can always concatenate lists if we want. So this is going to give us 0, 1, 2, and 3. So this is the original list updated. But alternatively, I can use a method instead. Now, we're going to discuss this a little bit more next week when we start doing object-oriented programming. Believe it or not, we're putting the bow on imperative programming today and starting the second module next week. But sometimes we'll have a function. Here's a good example. So here's a list. Okay. And I want to sort this list. So there's 2 ways I can do this in Python. Here's the first, I think. Right. And that's a function. That's a function which, given a list, returned a list. But the other way of doing this is, here's X's. I can give a directive to X's to sort itself. Nothing showed up, but look at X's now. 1, 2, 3, 1, 2. It's been sorted, right? So there are 2 ways that we can actually have actions in Python. One is a function, where you give me input and I give you output. And another one is this object-oriented type of philosophy where I say, here's an object, and this object has a method called sort, which is an instruction to like change its internal state, right? So we'll have a much wider discussion about this next week, but that is the technical difference between a function and a method, right? So here's the method for appending. So I can say x is dot append to the end of this list 3, and we're going to get 0, 1, 2, and 3. So here's how you can add to the end of the list. What happens if I append the list 4, 5 to the end of this list? What is x is going to be? You would be absolutely correct, right? Because this is an instruction to Python to append to the list x's the element 4, 5, which is the list. Right, so this puts in a list at the end. So be careful. This may not be what you want. There's another method called extend, where I can say x's extend yourself by the following list. And what this is going to do is sort of concatenate those two lists together, right? So this is sort of similar to saying, plus 4, 5. Now here's a little sort of spanner in the works. Okay, so because lists are mutable, we don't actually store their value in the name. Why? Well, because the value can change at any time, right? This is much different than when we put the value 7 in x. 7 is a constant. So if I'm using x or 7, it doesn't really make a difference. Now I'm saying, oh, let's put this list into the name x. And by the way, the list can change at any given time because it's mutable. So what we're doing instead of putting the value into x's, because there is no value, is we're putting a reference to the list into x's. X's is saying the list is over there in memory. Right? So when I say this is, we have to sort of view this as saying, x's gets assigned a reference to the location of the list containing 1, 2, and 3. I know this is sort of very verbose, but that is what is happening. Okay, so using that logic, let's try to work some of these things out. If I then say y's gets x's, what am I saying here? I'm saying y's is a name which is getting the value that x's is storing, which is a reference to the list 1, 2, 3. So y's now has a reference to that list. So if I tell y's, take your last element and change it to 9, y's is going to look like this. What's going to happen to x's? It's also going to be 1, 2, 9. Right? Because you have multiple references pointing at something that can change. So you have to be really careful working with lists. Right? Because they can, if you pass a reference to somebody and that somebody changes the list has changed for everything pointing at it. Okay? So this is the really big hurdle when working with lists, that you can't treat them like a value. You have to treat it like a reference. And C, this is a lot more explicit, right? Lists, you can't really have a list. You can really only have a pointer to a continuous part of memory. Yes, miss? Yeah, you can have arbitrary number of pointers to a location to the same location in memory. Yeah. Yeah. Sure. So there's x's, and I can actually say, like, that's its memory location. So every register in memory corresponds to a single integer. And that's the integer that corresponds to where the first element of this list is in memory. If I were to say y's is equal to x's, like y's would have the same ID. Right? So it's almost as if we're putting these IDs right into their list. But don't worry too much about these IDs. Oh, except that like this is the only time you're ever supposed to use the keyword is. It's like when you're checking to, you're asking if the memory locations are identical, not if those integers are equal. But anyways, don't use is. You're probably using it wrong. Okay, so if I'm just copying aliases, that, like, what happens if I actually want a duplicate of the list, right? That I can use without destroying everyone else's version of the list. Well, I can just do a copy. So if I put into y as a copy of a list, what this is going to do is it's going to make a duplication of this list in memory at a different memory address and then put that memory location into y's, right? So if I now change y's in this instance, x is going to stay static because you have two lists that at one point had identical elements, but at two different memory locations. So that becomes 1, 2, 9, right? So like this is why working with lists can sometimes get tricky, but if just remember that you have an alias. Yes, sir.
That method of saying y to x is square root thing.
Oh, in terms of using a list slice, I think that's actually my next slide. In terms of like what you see downstream, no. But there may be like technical like I usually using the method is a lot better somehow because they've optimized it, but that's beyond like what we care about in this class. So my two answers are no and yes. Okay, cool. Passing lists to functions. Okay, so more nuance. This is more nuanced now when you're passing lists to functions, right? Because normally we're used to like passing stuff to functions and being able to do whatever we want within functions without worrying about what we're doing with inside a function having any effect outside of that function. This is no longer the case when you start passing functions references. All right, so I have a function foo. It's going to take a list and it's just going to change the first element of a list to -100. So here's a list x's. If I pass x's to foo, x's is going to be given to foo. So the reference to x's is going to be put into y's. And then y's is going to change its first element to -100, but y's is pointing at the same thing as x's. So what will x's be outside of this function? Its first position will be -100, right? So if I have a function, I passed a list to it, and that function actually had made changes to that list that were visible outside of that function. So again, like I'm just cautioning you to try to be very careful when using these lists because they have a different behavior than passing values. My son, can you not annotate? Thank you. I actually tried to wipe that off of my screen because I was feeding my toddler noodles yesterday. And it looked exactly like a noodle. Anyways, alias, what is this? Okay, so let's just go through this one. So x's is 1, 2, 3. If I make y's point to x's and I append to the end of x's, y's is also going to be appended for. If I say x's plus equal 5, right, which is a short form that we have that's supposed to mean x's is equal to x's plus the list 5, y's will also change. But if I do x's is equal to x's plus 6, right, attempting to concatenate 6 to the end of the list, y's doesn't get that. Okay, so this is just a nuance in Python, right? That you would think these three ways of appending to a list should be identical in behavior, but they're not. So what I recommend doing is just use append. Just use it and don't do the other ones, right? Because if we all agree to use append, then we're all going to have predictable behavior in our code. But just, I remember last year, a lot of people had some pretty serious bugs that were created by doing this rather than doing this, even though we thought that they should be equal. So I'm just giving you a little bit of a warning. Just use append and this won't be a problem. Type hinting is a new feature in Python 3.9 and greater. It's really nice that we can say, here's x's. I'm going to take a list of integers, right? We use the square brackets here because it's a type hint. Sort of the notes haven't been updated to use the type hints. I've been writing new notes. I try not to talk about it too much, but I'm trying to get you guys a set of course notes before the exam. So just keep this in mind, right? That if you're getting errors about your type hints not being accepted by Python, you're probably not on Python 3.9 or greater. But this is how you type hint a list, right? You can say, I have x's, I have a list, and to tell me what's inside the list is actually optional. So let's write this function. Return the number of times members of x's are in y's. So I think this is maybe one of your Shifu homeworks as well. But here's a function, and I want to count the number of times members of this list appear in members of this list, right? So 1 is in here, 2 is in here, 3 is not, 4 is not, right? So twice. 1 is in here, 2 is in here, 2 is in here, 2 is in here, 1 is in here. So that happens 5 times. So let's just code that up. Definition count. I'm going to have x's. That's going to be a list of integers. Going to have y's. It's going to be a list of integers. I'm going to return an integer. Count. Okay, so again, I have to count something. So I'm just going to have an answer. I'm going to return it. I'm going to start accumulating from 0. So what do I want to do? So let me take my usage example. Or I'll take the... Okay. So I want something like count 1, 2, 1, 2, 3, and this should be 2. Okay, so 4. So I want to first look at every element of this and ask if it's an element in here. And if it is, I want to increment my accumulator. So I'm going to say something like for y in y's, if y is in x's, then increase the accumulator. Something like this. So I can say something like, let's count 1, 2, 1, 2, 3, 2. Let me try to add some more stuff here. Whoops, unmatched bracket. Oh. Yeah, that seems to work. I'll show you sometimes it's fun. At the end of the year, I'm going to show you some functional programming, which means that a lot of these functions that we write can actually be designed with one line. So here's the one-line solution to this. Return sum y in x's for y in y's. Ta-da. All right, so by the end of term, we'll learn how to do all of these like really fun, nice one-line solutions to functions. That's called functional programming. I teach a whole class in it. It's real fun. Here's another one, make unique. Let's write another function that, given a list of integers, returns another list back, where the list that we're returning is the list of the unique members of the list that was input, right? So if I had the list 1, 2, 3, 4, that's already comprised of unique elements, so I just spit it back. If I have the second list with like a bunch of duplicate 2s, I simply remove all the 2s and the 1 and the rest. So let's try and program this one. I'm just going to call it foo. Def foo. I'm going to be given a list of integers, and I want to return a list of integers. Okay, so I want to return an answer. So I'm always accumulating in many of these exercises. But what am I accumulating from here? What is my 0? What is my empty of the return type? Right? So I need to return a list of integers. What is like the smallest list of integers? Empty list. Yeah. Empty list. Sorry, I didn't. But yeah, I guess you're right. Okay. Empty list, right? So I'm going to start accumulating from the empty list. I'm going to use append, which is the new method that we've learned for adding to this. So I want to do something like for x and x's, like look at every element of the input list. And I want to add it to answer, but only if what? Like I want to say something like, okay, yeah, append this x to the answer. But under what condition should it be appended? Yes, if x not in the answer already, then add it to the answer. Okay. So I should be able to do something like foo 1, 1, 1, 1, 2, 2, 2, 2, 3. Aha, unique list. Okay. So that one's not too bad either. Slicing. So you can slice lists the same way that we slice strings. I think in the interest of time, I'm going to go through this pretty fast because it's all the same messaging that we did with strings, right? You have 3, which is the starting point on the left, which is inclusive. 6, which is the endpoint on the right, which is exclusive. So x is from 3 to 6 will give us the position, will give us the numbers 3, 4, and 5, because 6 will be excluded. The third element here is an optional element for the step size, right? So this means start from the leftmost extreme, go to the rightmost extreme, and count by 2. So you're going to go 0, 2, 4, 6, 8, 10. That's beyond the right extreme, so it's excluded. I can say go from the 7th element to the 2nd element, but walk backwards by -2. So that's going to be 7, 5, 3, and then nothing. Yeah. They're pretty useful. It just takes a little bit of time to get used to them. Yeah. This one? Yeah, so this says start from position 3. Oh, yeah, it should be 2. It should be 2. Yeah, that there should be a. Am I losing my mind? No, hold on. Should it be 2? 0, 1, 2. Well, this is the 3rd index, isn't it? Yeah. Don't forget, we start the. Oh no, this doesn't mean in the list find 3. This means start at the 3rd index. And yeah, so I made this list special so that its indexes and elements correspond. Maybe that actually made it more confusing, but here we are. Okay. Okay, here's an interesting exercise because it's an informative one in terms of having confirmation bias. Okay. So when we write our functions, you need to test your functions. And here's the wrong way of testing your function. I'm going to make sure that here's a bunch of places it should work, and it works. That's not really that great. Like, you need to test it more comprehensively than that. Like, you need to take more of an adversary. You need to try to break your function. You don't need to try to make your function work. Right. So this is going to be good because it's hard to get this one right on the first try. And there's like a really pernicious bug in it. Okay. So here's a list 0, 1, 2, 3, 4, 5. And I want to rotate it by 2, which means that like we're going to put the 0 at the back and all of the elements are going to go down by 1. I'm going to put the 1 at the back and then all of the elements are going to go down by 1. That's what it means to rotate 2. So I'm just going to grab this. Okay. Whoops. Okay, so let's rotate 1, 2, 3, 4, 5 by 2. That should give us 3, 4, 5, 3, 4, 5, 1, 2. Okay. So how can I do this? Using slicing. That's the tool that we just were given or put into our Python toolboxes. Like, we can very easily solve this problem using list slicing. I don't actually want to like move an element to the back and like move everything down. That would be bad, right? So how can we do this with the list slice? Yeah. Yeah, exactly. We want to do something like x's start at k, go to the end. And then we want to add x's starting from the beginning and stopping at the end. Okay, let's see. Rotate 1, 2, 3, 4, 5. Oh, I have to give it a second. By 0, by 1, by 2, by 3, by 4, by 5. Cool. So works perfectly. Send it off to production, gold disk. Do we think that this works? Right, I just ran it across all of the inputs, right? It worked 6 times. Yeah. Okay, let me put in, I'll be a little bit cheeky. So we don't have to worry about negative rotations. Yeah. Let's keep going, okay? 6, 7, 8, 9. Is that right? No. So is this function correct? No. So this is a good lesson, right? Because we may have been tempted after doing these to be like, it works so well. right? But first of all, negative numbers, that was a good observation. But if we go beyond the whole length of the list slice is going to be empty and full. How do we fix it? What's the problem here? What does it mean to rotate this list by 5? What will happen? It's a full revolution. It's the identity revolution. Nothing actually happens. So what we have to do is remove all of these identity revolutions from K ahead of time. So what do we only care about? The remainder. Do we have an expression for that? Mod. Yeah, so I'm going to do something like, okay, we need to do something like, I'll call this K prime, where K prime is K mod out the length of the list, right? I've removed all the identity rotations. And so, whoops. Is it length? Jeez. Oh, yes, sorry. Okay. Okay, so this is rotate 5. This is rotate 6. Yep, this is rotate 100. This is rotate 101. Right, so now it works. Okay, but this problem really wasn't on list slicing and adding stuff together. Again, look, I want you to remember this when testing your function. And remember that we were so confident that this function was working perfectly because we tested it on all of the inputs and it was working. Try to break your function. Better yet, give it to someone else and say, try to break this. That's the whole purpose of QA testing. So you have to be more of an adversary for yourself when doing this. You may be surprised because remember, the grade scope test that you see preliminarily, the grade scope test that you see originally are only a subset of the actual number of tests that we run. So we're giving you basically like 10% of the tests. But just because you pass all of those doesn't mean you're going to pass all of the tests, right? It's incumbent on you to actually do a little bit more of testing on your code. This will just prevent you from getting a 0, right? Because if you have like a misplaced semicolon in your code, our grader can't read it, and you could get 0 for what would be weeks of work. So just keep that in mind. Only 50% of you have actually uploaded to Gradescope. My initial instruction was to immediately upload to Gradescope with the number of hours, because for one, if you don't have a Gradescope account, we need to get you one. Okay. If it's the hour to deadline and you're emailing us frantically trying to get access to the Gradescope, you may get 0. The other important thing here is if you want to apply for an extension, if you've done 0 work, that's grounds for declining you an extension. Right? Because we've provisioned 3 weeks to be working on this. So when admin says, well, you've done nothing over the last 3 weeks, so we're not giving you an extension. Being sick on day 21 of a 3-week project doesn't entitle you to say, well, that's why I got nothing done the whole time. So if you upload to Gradescope, this will demonstrate to the people who are able to give you extensions that you've actually done some work ahead of time. I am not authorized to give extensions. I just want everyone to know that, right? So if you email me saying, please, sir, can I have an extension? I'll say, go ask the person who's actually capable of giving this to you. Because of course, if it was up to me, all of you would get extensions all of the time, right? I'd be so gracious and accommodating, but I can't. Hands are tied. Range. So this is a special keyword in Python that allows us to rapidly build lists that are comprised of integer ranges effectively. It's a little bit more complicated than that because a range is going to be a delayed data type. Something that's special about Python is that it does everything lazily, right? It won't actually compute something unless it absolutely has to. So if I say, give me a list of 10 numbers, Python will say, here's a list of 10 numbers, right? But it's not actually going to tell you what they are because it's lazy. Right? It's only going to generate the numbers when it's necessary. If I ask for what the type of range is, it's going to say it's a range. If you want to actually see what's in the range, then you can say, convert this range to a list, and then you'll get all the numbers back, right? But effectively, a range is just a way for us to generate quickly a list of numbers that are consecutive in some manner. I can say, give me a range from 2 to 7. That's going to be the numbers 2 through 6. I can say, give me a range from 2 to 7, but increment by 3. That means we're going to start at 2, then go to 5, go to 8, which is beyond 7. So 8 is excluded. So you get 2 and 5. I can say, start at 2, go to 7, but walk backwards. How many numbers are going to be in this list? Can you walk backwards from 2 to 7? No, empty, right? What about walking from 7 to 2 backwards? That we can do. But the last thing here is 3, right? Because we're exclusive on the right endpoint. This is kind of confusing because the endpoints have swapped. We're walking backwards down it. Range can be used to walk through lists using an index, right? So if you're from C or Java, some place where you don't have this nice for loop, this may be the traditional way that you're used to doing it. You're saying, I have this list X's, and I'm just going to say, give me a K that corresponds to every index of this list. So 0, 1, 2, and 3. And then I can access these X's by X's at 0, X's at 1, X's at 2, X's at 3. Right, this is sort of an older style of programming. I don't like it because it's very error prone, right? These keeping track of what these indexes are, it's tough, right? So I would caution you against doing something like this. This is an older style of programming. If you really do want, or in fact need the index of the value you're working with, there's another function in Python called enumerate, right? So I can say enumerate over this list, and enumerate is going to return a list of couples where the couples are the index value pairs. So I'll show you how this works. So I can say something like, here's X's 1, 2, 3, 4. For K, the index, and XK, the value, enumerate through X's. Right, so at every iteration of this for loop, I'm going to have a value xk, and I'm going to have a value k. Right, so I'm going to have the index and the value from the list itself. Right, so if you do want the index, use this enumerate. What will this print? For kx and enumerate, scientia ac labore, print kx. Well, it's going to print 0, scientia, 1, ac, 2, labore. Who recognizes this? Huh? It's the motto of the university. Only one person bleeds purple here, it seems, right? So this is the UQ model, by means of knowledge and hard work, right? This is the slogan of the university. It's certainly something that we're going to need in spades in this class, but like I should mention that like it's very possible to do well in this course. And like, we're all really rooting for you. I love programming computers. I think it's like really beautiful and elegant. And like, I hope that sometimes my enthusiasm comes through. But yeah, keep showing up, keep working hard, and it's going to be worth it. Like if eventually all of you are going to be bitten by the computer bug. And once that happens, it's really, I don't know, once you can really start enjoying getting stuck looking for bugs, right, your life will change. Yeah, programming is way better than like having children, for example. Okay, nesting for loops. Some of the parents are laughing. Okay. So whenever I give you a control structure, or anything for that matter, like we're allowed to recurse. We're allowed to use that control structure in a control structure. Like I can put a list in a list. I can put an if statement in an if statement. So I can put a for loop in a for loop. We're going to do this quite often. And what we learned last week is that the way that we resolve these for loops is inside out, right? The innermost for loop has to exhaust before the outermost for loop gets to increment to the next one. So if I give you a bunch of digits in a list and a bunch of alphas in a list, and I say for D in digits and for A in alphas, and I print D plus A, what's the first thing here that's going to print? I actually think this may be an error. Okay, so the correct answer is this is going to produce an error. Huh? Value error. I'm trying to add an integer to a string. Imagine there are quotes around this 0 and this 1 and this 2. Then it will work. Yeah, I'll fix it. Zero A is the first thing that's going to print. What's the next thing that's going to print? 0B, right? So the innermost for loop exhausts, and then the next for loop gets to reset itself. So yeah, once this inner one exhausts, then D increments to 1, and then this starts over. Like you don't get to the end of the list and then are always at the end of the list. Every time you start a new for loop, you start at the beginning again. A list can have another list as an element. But this isn't really the full story, is it? Because I said we can't really have values stored in variables. So what is this? Well, this is a name X's that is a reference to a list of what? List of references to other lists, right? So that's how you have to see this, as a reference to memory, where that memory itself is holding other references to other places in memory, right? So like, again, this, you can think of this as a list of pointers, or most accurately, a pointer to a list of pointers. So if I ask for the length of x's, what am I going to get here? How many elements does x's have? 2, right? Because it's a list comprised of 2 sublists. The first list has length 2, the second list has length 3, but the overall list has length 2. What's the length of the list that x is at -1? 3. Okay. So recall that loops can be nested. So if I give you a list of lists, how can I look at all of the individual elements inside the list, right? Suppose I want to, count them or something like that. Then I can do something like this. For x, and notice that I've like double pluralized this now to indicate that this is indexable and the things that I'm indexing are also indexable, right? So I'll always add an S for every level of recursion in terms of this structure. Yeah. We don't care about efficiency in this class. I care, like, program literally anything that is correct, and I will be over the moon. We can talk about efficiency at the higher years. But yeah, like generally speaking, we don't want to be putting for loops in other for loops. So, okay, you don't have to work at asterisks. Okay, your program has to run on a computer. That computer has finite memory and resources. So like you can't, if you put an infinite loop in your homework, like we're going to cut you off, right? So what I'm going to say is, like, we've allocated for you, but at your level is effectively an infinite amount of resources, right? And if you exceed it, there's something critically wrong with your code set. But the grader will tell you this. Like if you submit an initial submission that is like bad for efficiency reasons, it will say, I timed out, give it another go. Or, and I've never seen this from this class, I'm out of memory, try again. That's really common in my 3400 level class. They always blow up the memory. But I used to do this on purpose when I was in school. Like we were really bored in our computer science class. So like every time homework we would just log into the online assignment system and crash it. So they had to push the deadline back, and we just keep repeating it until the professor got so frustrated with us doing this that he hired us to fix it. and that actually started off my adventure into being a TA and then eventually a teacher. But sometimes you get rewarded for breaking stuff is the moral of this story. Okay, so here's 2 loops. And I'm saying for x's and x's. So the outer loop is actually grabbing individual lists. And then I can say in the inner loop, okay, so you've grabbed some list. Now the inner loop, walk through the list that you've just grabbed, right? So for x's and x's, and for x and x's, I'm just going to print x. And this just tells print to not put a new line. Like I have very limited space on a slide. So that's the only reason I'm doing it. So we're going to get 1, 2, A, B, C, H, E, L, L, O. Right, I've managed to touch every one of these values. Here's some homework for you to do. And when I say homework, I mean something that you can do optionally. It's not going to be graded. It's just for fun. Some of you may be taking linear algebra. Any of you familiar with the term matrix? In math, we can put numbers into a box and we can add those boxes together and take cross products of those boxes and transpose those boxes. But the box of numbers is effectively just a list of lists, right? So this, we can regard this box over here as being a list of rows. So here's a list of rows. So I'm saying take this matrix and represent it as the thing on the right, as a list of lists. Here's how we can like access individual elements here. Okay, so what is A's of -1? I know, don't just, what is A's of -1 going to be? Are we all hung up on this ass man? It's 789. Thank you, everyone. Okay, what about ask from 1 to 3? What am I gonna get? Huh? You can never throw an indexing error when slicing. Yeah. Well, how many am I gonna get back? Well, this is the 0th position. This is the first position. This is the second position. This is the third. So can I slice from the first position to the third? That's going to give me the first position and the second position, third position exclusive. So this is going to give me 2 things back, but 2 things that are themselves comprised of 3 things, right? So I need you to see the inside of these lists as like an atomic unit. As of 1 is 4, 5, and 6. If I say as of 1, that gives me 4, 5, 6. And then I can do a secondary index on that to say, what is the -1th index of the first thing indexed as? And that's going to be 6. We don't do this in Python. For those of you who are from C programming, you may be used to invoking matrices like this. If you're a MATLAB programmer, you may be used to this, but we don't. This doesn't make sense. Like, this makes sense because this says, go to as, get me the first list from as, and then take that list and then get the -1 element from it. Okay, so don't be an ass. List indices must be integer slices, not tuples. Okay. I told you that this is actually not a list of values. This is a list of references. So what happens if I put into B's a copy of as? What have I copied? Like, what happens if I try to say, like, let's walk through this listing and see if we can work out what the output's going to be. Okay, so I have A's. I've copied it into B's. I'm saying B's, look at your 0th position, look at the 0th position of that, and put a 0 there, right? So that would be, I'm replacing this 1 with a 0. So if I look at it, it happened. What do we expect to be in A's? Do we expect A's to be changed or not changed? You're not changed, you're changed. It's changed. And the reason that it's changed is because what we copied were references, right? So A's has a reference to a bunch of references, okay? B's has a copy of that reference to the same references, right? So the outside list is different. The inside is still the same stuff, right? So this is all the trouble from pointers. So this is called shallow copying, right? If you have lists of lists, if you just do a copy, it's just going to copy the outermost type of information. What you actually want to do is copy the outermost information and move inside and copy again, and then move inside and copy again. So this is something called a deep copy. And if you ever want to do a deep copy, you have to call a library command. It's in copy. It's called deep copy. You shouldn't have to do this. I just want you to be aware with working with list of lists, because I think you may be doing that now, potentially working with list of lists. So you should just be aware of some of these pitfalls. So here's your little bit of an exercise for you to do for homework. There's a operation from linear algebra where we take these matrices and we can transpose them. So if a matrix is a list of rows, the transpose of that matrix is just inverting all the rows and columns. So you see this row 1, 2, 3 has become the first column 1, 2, 3. The second row 4, 5, 6 has become the second column 4, 5, 6. The last row has become the last column. So write a function that, given a matrix represented as a list of lists, outputs a new list of lists where that is the matrix transpose. Converting lists into arguments. So this is kind of fun. So suppose you have a function f and it takes 3 inputs. And you have 3 inputs in x. And you want to give that function the 3 inputs stored in x. So one way that you could do it would be f x at naught, x at 1, x at 2. But, so is this going to work if I want to hand f 3 values? Well, what is x? X is one list. How many arguments is f expecting? 3. So if I give a function that's expecting 3 inputs, 1 input, it's going to say, hey, I need 2 more inputs, right? Because I didn't give it 3 things, I gave it 1 thing that happened to be a collection of 3 things. Now, the way that you can get around this, you can use an asterisk on the left-hand side here. And this in Python is the unbracketing function. So if I say f, give it x, but take the square brackets off, and then that will work, right? This is going to put 1, 2, and 3 there. This is just kind of a neat little syntax. So tuples are immutable ordered collections, where lists are mutable ordered collections. Both can be sliced and indexed. So next, we're going to talk about string methods. I don't have time to do this extra Caesar cipher, but it would be interesting for you to do at home. So a Caesar cipher is one of the most basic types of encodings that we can do. Like we have a whole department here in cybersecurity, which we have arbitrarily sophisticated ways of encoding something. But given the alphabet, we can do a rotation, right? I can say A goes to Y, B goes to Z, C goes to A. That happened to be a -2 rotation. So what I want you to do is write 2 functions. One where I give you plain text, which is the message, and a shift. And then you return to me the ciphertext, that is the encoded text according to the Caesar cipher. And then another function, we're given this the text that's been encoded. Give me the shift and decode that ciphertext. That may be a little bit fun to do at home. Okay. How much do we got left? String methods and diction. I should be able to do this. Okay, so we're at the halfway point, and I promised to tell you my Eka story. So who wants to guess at the Australian icon that I basically walked into? Any guesses? Yeah. Okay, so if you guess it, well, okay, yes, up there. Robert Owen. No, have no idea who that is, but okay. Oh, it's Steve Irwin's son? Oh, no. I was going to say if it would have been the daughter, that would have been better. But okay, so I go into Eka. I'm there for like 4 minutes totally. I'm prepared for this day to be an absolute disaster, right? Because my wife has been preparing me for this. She's like, we're going to get like a disease like this. We're going to lose our son. We're going to be put in jail, whatever. Okay, so 4 minutes. We're going up the escalator because I have to go watch a 30-minute presentation from dogs who rescue people. I'm not quite sure how that works. Okay, so I'm like, I have my front-facing backpack because you have to reverse it so you don't hit people. I have my stroller. I have my son in the stroller. And I'm going up an escalator, and someone's coming down the escalator. And I'm looking at this person, and my brain just can't comprehend what I'm looking at. And we're coming closer and closer together. And as we come closer and closer together, my head keeps making more of a tilt like this. And my mouth keeps becoming more agape like this. And then she looks back at me and she goes, and it was Emma from the Wiggles, as Emma from the Wiggles. Now, the reason I was confused is Emma is no longer Emma from the Wiggles. She's Emma Memma. So she was dressed up in orange. So that's why I was so perplexed. I'm like, wow, that's super good Emma cosplay. But why orange? And that really does look like her. Oh my God, that's Emma, right? And if you think that was bad, has anyone seen Invasion of the Body Snatchers, the movie? So there's aliens in that movie, and the aliens go like this. And that's the reaction my wife had to Emma. Oh my God. So that was my story about the Eka. Within the first 4 minutes, I met Emma, dressed up as Emma. And on further reflection, this is the most famous person I've ever encountered in my life. I know it's a children's music star, but it's the biggest one in the whole world. I've genuinely met famous scientists, but I think Emma is now top of this list. So that's my story about how I met Emma Memma. Check her Facebook. She'll confirm that she was at the Eka the same day that I was at the Eka. So the story is at least plausible. So that's the Aussie icon that I meant. And that leads naturally into string methods. So in assignment 1 and in file processing in general, you're going to be working extensively with strings, especially if any of you destined for data processing. This is all data is stored as string data. Even numbers are strings, right? So we have a lot of interest in taking these strings and converting strings into data. So what I want to do now is take a look of the inbuilt commands that Python provides. We've talked about some of them. Like I said, look, we have arithmetic, we have things like length and print, but there are actually hundreds of built-in commands like this. And the way that you can see them is by typing into your REPL help. So in this case, if I ask for help on string, which is the class or the type, you're going to get a ton of information here. So if I do it here, if I can say help on string, this will keep going and going and going and going. There's like tons and tons and tons and tons and tons of information here. And what I want to look at are some of the available methods, right? So for instance, one of the methods available for strings is capitalize. And it's going to return a capitalized version of the string, right? So I can do something like here, say ABC dot capitalize, capitalize ABC. Right, so this could have been useful for some of like the earlier stuff that we're doing, but now we're allowed to use this method because we implemented it already. I would know how to do this if I was asked to do it. So we will eventually learn that strings are objects, and objects have methods, which are like functions, but have different invocation syntax. For instance, I don't say capitalize hello. This is how we call functions. When we use a method, the method is something that like mutates an object itself. So here we say hello.capitalize. Right? So functions and methods have different invocation style, and that this is going to be important. So if you want information on a particular string method, you can say help string.find, and it's going to spit out something like this. And the ability to read documentation is something that you need to develop. Like one of the questions on the exam last year was, here's some documentation. How do you now tell me how this function is called? So let me teach you how to read this. So this is the method that we're going to be using. And this is telling us like what its usage is, right? We can already see this is going to return an integer. So this is your string S. You can say dot find, that's the method. And we read this. So these square brackets here indicate something that's optional. Right, so we need to find, and you're obligated to give this first argument, but then you optionally can give the start argument, and then optionally give the end argument. So square brackets here and the parameters for find indicate the parameter is optional. So this rule recurses, that is to say, optional parameters can have optional parameters, right? Because the first one was required, the second one is optional, and the second one has a third optional command. So here are the comprehensive ways of calling find. So I can find I in team. That's fine. I can find I in team starting from 1. That's also fine. I can try to find I in team starting from 1 and ending at -1. That's also fine. But I can't say find 1 to -1 because this first position was required. Okay. Hello world, find world starting from 6. Is this going to work? 0, 1, 2, 3, 4, 5, 6. So is it going to work? Yeah, because we found world starting at 6. Hello, hello, find hello. Which one is it going to find? Well, we go here. Help. String.find. Return the lowest index. Okay. So if it's returning the lowest index, where are we going to find hello here? Where's the lowest first index where hello starts? 0. What happens if I start looking at 1? 6. Can I find hello within the subrange 1 to 3? So what does it return? -1, because return -1 on failure. That's why it's important to be able to read these docs, right? So you know what's going in and what's coming out and how to act on it. Convert a so here's an exercise. In this exercise, the answer is to find the string method, right? So if I were to say convert a string of text into the title format, A Tale of Two Cities should be converted to A Tale of Two Cities. We should be able to think, this seems like something that we'd be doing pretty, like this is a common operation of strings. It is probably the case that there's a string method for this. I'm going to go check if there's a string method before I program this. And indeed, yeah, if you look through the string methods, you're going to find the method for title. Right, so we could have answered this question simply by saying, yeah, C is not title, right? So it is perfectly acceptable if we ask you to program something for you to use the inbuilt stuff, right? You're certainly prohibited from calling in libraries, but do use the existing tools if they exist, and now you know how to find them using help. So the following may be accomplished by invoking the appropriate string method correctly. Write a function that, given a word an integer with, centers the word. Just in the interest of time, I'll tell you, like there is a method called center, which would accomplish exactly this. We just have to be able to read this, right? So returns a centered string of length width with this fill character, right? So I can say something like, take the word spam, center it in a field width of 10, and then like use X's as the empties, right? And that will solve the problem. 101 centered by 20 is X. This was useful last year because the students actually had to use this for their first homework. Split is an exceedingly useful command. So given a string, if you ask the string to split, the default behavior is going to split this on spaces. Right, so give me a string and split it, and I'm going to return to you a list of strings that are separated by that space. You think this is useful for A1? So in A1, what have we asked you to do? Right, we've said, here's the input move. It's a digit, a space, a digit, a space, and a digit. And then you need to get those digits out. Okay, but you can just split. And it's going to put all of those digits in a list for you. There'll be strings, but you just have to convert them to integers afterwards. So you should be looking at using this. It's a really useful command, this split. I'm actually able to, well, if you split and there are no spaces, you're just going to get the same word back. You can actually split on anything that you want. Right? I can say split on X. I get A, B, and C. Notice that the X's have been removed. I can split on more than one character, right? Because we don't even have a notion of characters in Python. This is going to be A, X, and C because we've split on this. Okay. There's something called the CSV file where every line of the file is a comma separated value, something that looks like this, right? So if I say A comma, B comma, C, and I split on comma, we're going to get back A space B space C. This is useful for CSV processing, but this is kind of annoying that we have this leading space here. Is there any way that we could get rid of this with a smarter invocation of split? Split on comma space, right? And then you get back something clean, right? So you don't always have to find a different method. Sometimes you just have to use the methods that you're using in a sort of more clever way. There's the opposite method here for taking a list of strings and gluing them back together. I always sort of switch this somehow, but this says using comma as glue, join together these strings A, B, and C. And so we're going to get A comma B comma C. Right? So that's how you can like stick stuff back together. You can actually join on the empty string, which is just going to do a, sort of the regular concatenation. And just here's some examples, right? Given me a list of characters, here's how I can join them into a string, which would be appropriate for a comma separated value file. And I can also join on like arbitrary gaps. Okay, so in summary, data types come with extra functionality by way of methods. In particular, there are many string methods that will aid with text processing. So if you ever need to do something with a string, look through all of the string methods to see if like the thing that you need already exists. So the final thing we're going to do today is dictionaries. And we'll finally be back on track. Okay, so speaking of ECHA tomorrow, so some of you are going to have tutorials that are obviously canceled. So feel free to go to tutorials that happen later in the week, right? But if they're full, we're going to have to ask you to leave. I can't guarantee. I also just can't cancel a week of learning because like we've lost a day. Also know that you can do the tutorials at home. I think there are also YouTube recordings of like a TA walking through the answer that we can release for this week as well. But moral of the story is try to go to a different tutorial later on in the week if you want. You can always give it a try. Okay. Dictionaries. So this is the final data structure that we're going to talk about. So the data structures we've given you are sort of integers, strings, tuples, lists, and here's the last one, dictionaries. You're going to be learning two things in your journey as computer scientists. You're going to be learning about algorithms, like techniques for doing stuff. But you also have to learn about data structures, how the data is stored in the first place, because how we store it, if we do it in clever ways, that could emit some sort of nice downstream effects. So, and how we represent something itself requires us to think. So here's a question which is deliberately vague. I want you to write a function that returns the character frequency of a string, ignoring the case. So for example, the character frequency of hello world, you need to encode somehow that there are 3 H's, one H, 3 L's, and so on. How do we do this? I know we can write a function that goes through and counts the individual elements, but what am I actually reporting back to the user? How do I actually represent the answer? Any ideas? What would you think to return? Okay, so from this side, someone said something? Yes, sir. What does that mean precisely? Like literally, what should this function return? A list of numbers, okay? So how do I get from your list of numbers to the character frequency? So you're returning 2 things now. We can't return 2 things. We can only ever return 1 thing. You can return 1 list of 2 lists. Keep going. You're iterating towards the correct answer. All right. Can anyone help them out? So the colleague up there says, return 2 lists. So what should those 2 lists contain? Yes, sir. Yes. Okay. I'm satisfied with that. So here are 2 ways that we could represent the answer here. The first one is the joint work of the back row. In returning 2 lists, where the first list are all the unique list of characters, and the second list are their frequencies, right? So here this says that H has 1, E has 1, L has 3. What's the problem with the first list? What's the problem with this representation? In order to find the frequency out for R, what do I have to do? Yeah. Huh? Well, yeah, like I have to find R in the first list, find its index, go to the second list, find that index and pull it out. Okay, that's not too great that I like in order to get the character frequencies, I have to start searching stuff. Okay, what about the second way? So the second way, I'm going to return 1 list. The list is going to be exactly the length of the alphabet. And I'm going to just say, hey, user, interpret the first position as the number of A's, the second position as the number of B's, and so on. How do I find how many R's are in this? Well, I know R's position in the alphabet. So I just go to that position in here and see that it's 1. Okay, so both represent the data. What's the disadvantage of the second one? Yes, sir. Yeah, well, like those zeros are pointless, right? Why it's bad to have to store all of these zeros. Okay, so is it possible to get a new data type which gives us the advantages of both and disadvantages of neither? Yes, right? And this data type is called the hash function, or as it's called in Python, it's called the dictionary. And a hash function, or what we call dictionary, is the most useful data type that we have in computer science, period. Right? It's so useful that you are going to be spending a lot of time studying how they work, right? Because at the moment, I'm going to tell you that they work by magic. That's and at higher levels, they'll call it an oracle, but essentially what they're saying is it works by magic. So in both cases of this encoding, what we had to do was just come up with some type of mapping to say, your H goes to 1, this E goes to 1, this K goes to 3, right? Both of those representations admitted this type of mapping. In fact, I can give you explicitly the way of doing this conversion, right? So if you give me 2 lists, this would be the hash function, right? So the hash function is the thing that I say, you give H to the hash function and H returns 1. You give K to the hash function and it returns 0. You give L to the hash function, it returns 3. And it doesn't have to do a lookup. This happens immediately. That's where the magic happens. So generally speaking, a dictionary is like a list but we're not limited to integer indexes. The indexes can be anything that we want, right? So a dictionary is going to be an unordered collection of tuples where these tuples are key value pairings. And Python has a magic hash function that knows how to index anything, right? Somehow when I say, tell me what's in this list at position hello, it knows what that means, right? And if you want to really flesh that out, we got to wait to the higher levels. Okay, so here's how we could encode the answer to the original question as a dictionary. This is a dictionary in Python. It's a set of these key value pairings, right? So that's what the colon here is used to say D is a key that maps to the value 1, right? So let me just go here. I can show you how it works. So I can have D, a dictionary, and I can say something like A goes to 1 and B goes to 2, right? So there's my dictionary, and I can do things like say, what is D of A? What is D of B? Okay, so it's just a way better type of, or more robust type of indexing. So a dictionary in Python is a data structure that stores these key value pairings, and Python has a magic hash function to find these. Here's the nomenclature for these things, or here's some methods for dictionaries. So we have an items method, a values method, and a keys method. So each of these individual elements here is called an item, right? The key value pairing. So if I ask for all of the items, it's going to return to you a list. You don't ever really need to use this. The same thing for the values. The values here are going to be everything on the right-hand side of a key. So the values here are the apples, the fire trucks, the cars, like a list of the lists. And the keys are all of these things that are colors here, right? So this is a dictionary keying colors to list of things that are those colors, right? So things that are red, apple, fire trucks, cars, things that are yellow, banana, cars, things that are blue, sky and cars. So the keys here are going to be red, yellow, and blue. Now, if I ask for H of blue, what am I going to get? Sky and cars. What happens if I ask for H of green? Let's predict the outcome. Let's predict the behavior of Python here. Perfect. Yeah. So we've keyed out of lists before, right? If I have a list that's length 3 and I ask for its 100th element, it's going to say index does not exist. Well, this is basically an analog to that, right? I'm asking to retrieve a value for a key that doesn't exist. So error, key, green not found. Okay. What happens if I put something in? If I'm saying H of green, put in leaves. That's fine. It's always okay to create names, right? It's never okay to just ask for what a value a name has if it hasn't been instantiated yet. So the same problems that we had for lists are going to be at play for dictionaries, because dictionaries are also mutable, right? So since they're mutable, we're not actually holding their value, we're holding a reference to them. So you're going to need a copy. You may need this clear, but just keep in mind all of these references and the problems intrinsic to them is going to be at play for dictionaries. So there's this get command. This sort of saves you from key errors. So I can say h.getRed, and it will faithfully return the value for that. H of green throws an error, but if I say h.getGreen, it's going to return none instead of erroring. And none is better than error. Error will, like, if an error is in your code, your software will stop running. It's done. It's over. If you get none, that's something that you can sort of say, oh, it was none, try again. So get is one of your tools for not throwing key errors. I actually prefer doing it this way. So a dictionary is also an iterable, right? I can do something like say, for K in D, print K. What do we notice here? I'll write it again. Here's my dictionary D saying for K in D, print K. So I was walking through the dictionary, but what is K being set to? The keys, right? So you can naturally, if like a dictionary is already primed to be walked by a for loop by walking its keys. Okay, so that's important. So if you do something like this, you're guaranteed
to not throw a key error, because the only keys being made available to you are the keys from the dictionary, right? So this for loop is totally safe. Otherwise, outside of a for loop, you do need to check before you key a dictionary that key exists. So one option is to use this get. Another option is to do this. I can say, if the key is in the table already, okay, we're fine. Go and try to access table at key. Otherwise, put it in, right? So before you access something from a table or a dictionary, you have to be very sure that like you're keying something that exists. And the two ways of ensuring it exists is being in a for loop, because the only keys that you're being given are ones from the dictionary in the first place, or using this type of if statement, or using get. And so those are three ways at least. Let's see. Write a function that when given a string returns a dictionary whose keys are characters and values are the positions of those characters in the string. Let's do this one, and I'll send you away. Let's just study the example. So here's a string, little a, big A, little b, big B. And I want to return a dictionary that maps A, the character, to the positions in the string, right? So we can find A at position 0 and 1, B at position 4 and 5, capital A at position 2 and 3, and so on and so forth. Okay. So let's just program that one up. What was like, we're given a string, and I'm returning a dictionary, and this dictionary should key strings to lists of integers. Okay. So what do I want to do here? In the last 5 minutes, it's going to take this example. Now, so this needs to be something like A goes to 0 and 1, capital A goes to 2 and 3, and so on. Okay, so how can we do this? So now I want to have an answer, and I want to return the answer. But what am I returning in this case? A dictionary. What is this? What should I start accumulating from? What is the smallest dictionary? Empty dictionary. In that case, you do it like this, or alternatively, you could have done it like this, like empty square braces. Okay, so the next thing I want to do is for k, x of k in enumerate c's. Remember, we learned this a little bit earlier. I'm grabbing the actual characters from the string, and I also, in addition to that, have their index, because I need that in this case. And I want to do something like, okay, so I have I have the character, I have the C, the character, and I have its position k. So I want to do something like, if xk is already a value in the dictionary answer, then all I have to do is look in the answer at the key xk and append to it this new index, right? Otherwise, it doesn't exist, in which case I just need to instantiate the list. All right, so let's see if this works. Foo of AA, BB, BB. Ah. Any questions with that? Oh, okay. What else do we have today? There's the answer. Okay, so here's some. Maybe we can take this up at the next class, but let's just look through these. So here's some homework for you to try. So given two dictionaries, return a new dictionary where the new dictionary has keys which are common to the keys of the first two dictionaries. There's the answer, trying to look it up. Write a function that does a reverse lookup. So that is, if I give you a value, I want you to tell me all the keys in the dictionary that correspond to that value. Write a function which inverts the keys and items of a dictionary, right? So if you go from the key 1 to the value 10, the key 2 to the value 10, we want a new dictionary where the keys now are the values, right? So we have to go from 10 to 1 and 2, right? So this isn't sort of not invertible. So we'll do these. We'll go over it next class. And so in summary, dictionaries are for storing key value relationships. A key is mapped to a value using hash functions that are magically fast. Next week, object-oriented programming. We're done imperative programming. So you now have comprehensively, definitely all the information you need for doing A1. Get a grade scope submission up, or there's very little I can do to help you into the future. Happy Eka, everyone. Have your strawberry sundae and don't make a fool of yourself in front of Emma. Bye, chat. How you going?
Good. I had a question about the final and like for graduate students and stuff like that, because I know for the assessments, it's like there's increased.
Final's the same for both
Okay,
groups, yeah.
and then how many points is the like supplemental for the assessment worth? Because I'm not like
You mean supplemental?
for like graduate students, like because there's like a increased amount for like the assessment one.
Oh yeah, you just have to do like an extra task.
How much is that worth though?
It-
Like in terms of like the grade, if I don't do that,
You won't pass.
I won't pass.
It's hurdled for you guys because you guys are getting a graduate certificate.
To do the extra part, right?
You're a 7,000 level student.
I am, but I'm in the business graduate student. I'm not a CS major.
Yeah, if you're 7,000, you have to do that. Well, I'm not actually sure that's how we worded it. So,
Because in the like,
I guess you can skip it, but then you're going to take a big hit. So you're asking me how much you're going to take a hit if you don't do the
like the extra
extra
part.
task. And
Yeah.
my answer is I don't know offhand. If
Okay.
you ask me that question on the EdStem, then I can rope in the person who wrote it and he'll have the
Okay.
answer.
Alright.
It's not going to be like, honestly, the assessment grades don't matter that much.
Okay.
Your grade is totally, well, mostly going to be determined by how well you do on the.
Yeah, I
on
just
the
want to make
final.
sure that if like I can't do it, then I don't like fail the entire assessment because then it doesn't really make sense.
You're not going to fail the entire assessment, but I would say that it's not grossly more difficult than the normal
Okay,
task. It's
okay.
just one sort of nominally extra thing.
Okay.
Because we have to give you, it has to be different in order for us to give you a degree certificate from
Okay.
like a accreditation standpoint.
Okay.
They came and they say, if these two classes are identical, you're not allowed to give 7,000 level
Alright.
students. So, but yeah, ask me on the EdStem, we can give you
Okay.
a more accurate answer. How you going?
Today, good. I just have a